Hello, chemistry students. Today we are going to talk about limiting reactants. So what is a limiting reactant? Well, they're the reactants in a chemical process or a chemical equation that prevent you or limit you from making more product. Your reaction runs out of the limiting reactant before any other reactant. So how do you know if you have a limiting reactant problem? You will be given the starting amounts of both reactants, and you're going to be asked to find the maximum amount of product that you can produce. What are the steps? There are 4 of them. The first step you're going to do is find the theoretical yield of both of your reactants. And you're going to have to find out how much product. You can choose your product if you're given more than one. It doesn't matter which one. Just be consistent and do both product or do the product the same with both reactants. And whichever product's the smallest amount or produces the smallest amount is the maximum amount of product that you can make. Step 2 is you find the limiting reactant. The limiting reactant will be the reactant that makes the least amount of product because it prevents you from making more, or it limits you from making more. That's why it's called the limiting reactant. It limits you from making more product. Third step is to find out the amount of limiting reactant left over. That's easy. It's always 0 because you always use all of your limiting reactant in a chemical process. And the last step is to find the amount of excess reactant. So one of them is the limiting reactant, which you have 0, and the other one will be the excess reactant, and you have leftover of that. And in order to find out the amount of excess reactant, you have to take the amount of the limiting reactant that you used, and then do that stoichiometry problem again, and calculate how much of the excess reactant that you should have used, that you actually used. Then you subtract it from the amount that you originally started with. So it's the original amount minus the used amount is equal to the leftover amount of the excess reactant. So now let's start with a problem. So we have 15 grams of hydrogen are mixed with 40 grams of oxygen to form water. What is the limiting reactant? So the first thing we're going to do is write a balanced equation. We have 2 moles of hydrogen plus 1 mole of oxygen yields 2 moles of water. The next thing we're going to do is write down what we know. We know there are 15 grams of hydrogen we're starting out with, and we are starting out also with 40 grams of oxygen. Now one of those is our limiting reagent, and one of those is our excess reactant. And we need to find out which one's which. So the first thing we're going to do is we need to find out how much water is formed from each of those. So from 15 grams of hydrogen, we're going to go to moles of hydrogen, then moles of water, and then grams of water, and find out how much water 15 grams of hydrogen can make. After that, we're going to do another stoichiometric problem and start out with 40 grams of oxygen, go to moles of oxygen, moles of water, and then grams of water, and find out how many grams of water 40 grams of oxygen can make. Let's start out with the hydrogen first. All right, so I'm starting with 15 grams of hydrogen, and it says I need to go to moles of hydrogen. So that's what I'm going to do. I'm going to put moles of hydrogen up here at the top. Whatever units are in the upper left, I always put on the lower right. If it is not a mole, I always put a 1 next to the mole. And now this number right here, grams of hydrogen per mole, that is molar mass. And the molar mass of hydrogen is 2 times the atomic mass of hydrogen, which is 2.02 grams per mole. Now, I'm not looking for moles of hydrogen, I'm looking for grams of water, so I need to keep going. Now it says once I've gone to moles of hydrogen, I'm going to go to moles of water. So I'm going to write moles of water. And whatever units I have on the upper left, I always put on the lower right, so I'm going to put moles of H2. This is a mole-mole ratio. I always look at my balanced equation right here to figure out the numbers that I put for a mole-mole ratio. Moles of water, right here it says I have 2 moles of water, so I'm going to put 2. Moles of H2, I look right up here in front of H2 and it says I have 2 moles of H2. So I'm going to put a 2. I don't want to stop with moles of water. It says here I need to go to grams of water. So I am going to add another grid. I'm going to grams of water, so I'm going to put grams of H2O. And whatever units I have in my upper left, I always put on my lower right. Moles of H2O. I'm going to look at my units to help me figure out what numbers I put here. I have a gram mole. If it's not a mole, I always put a 1 next to the mole. In grams per mole of H2O, that is the molar mass of water. And I'm going to figure that out by 2 times the atomic mass of hydrogen plus 1 times the atomic mass of oxygen. That is 18.02 grams. Now I'm going to take 15 divided by 2.02 times 2 divided by 2 times 18.02, and I am going to get 133.8 grams of water. That is how much 15 grams of hydrogen can make. We're not done yet. We need to find out how much 40 grams of oxygen can make of water. So let's do that. So we are starting out with 40 grams of oxygen. And it says that I'm going to go to moles of oxygen, my mole map. So I'm going to go to moles of oxygen. Whatever units I have in the upper left, I always put in the lower right. So that's grams of oxygen. I use my units now to help me to determine what numbers I put in front. I have a mole gram. If it's not a mole, I always put a 1 next to the mole. And I've got grams per mole of O2, that's molar mass. So I'm going to look on the periodic table and find out how many grams are in 1 mole of O2. I have 2 oxygens, so I'm going to multiply that by the atomic mass, 2 times the atomic mass of oxygen, which is 32 grams per mole. I'm not stopping at the moles of oxygen. I need to go to moles of water, so I'm going to add another grid. Whatever units I have in the upper left, I always put in the lower right. It says I'm going from moles of oxygen to moles of water, so I'm going to put moles of water right here because I'm coming from moles of oxygen. Going to moles of water. This is a mole-mole ratio. I always look at my balanced chemical equation for my mole ratio, so I'm looking for water. Right here's my water. It says I have 2 moles of water. Now I'm going to look at my moles of oxygen. Right here is my moles of oxygen. It says I have 1 mole of oxygen. I need to go from moles of water, which is where I'm at now, to grams of water. So I'm going to add another grid. Whatever units I have in the upper left, I always put on the lower right. So I've got moles of water on the upper left. I'm going to put moles of water on the lower right. Up here, I'm at moles of water. I'm going to go to grams of water, so I'm putting grams of H2O right up here. Now I'm going to look at my units to help me determine what numbers to put here. I've got grams and moles. If it's not a mole, I always put a 1 next to the mole. Grams per 1 mole of water. Grams per mole, that's molar mass. So I'm going to look at the periodic table and find the molar mass of 2 hydrogens plus 1 oxygen. That happens to be 18.02 grams per mole. So I've got 40 divided by 32 times 2 times 18. That is 45.05 grams of water. Now, 40 grams of oxygen will make 45.05 grams of water, and we just determined from the previous slide that 15 grams of hydrogen will make 133.8 grams of water. So which of these limits you from making more water? Hydrogen or oxygen? Well, it is the least amount of product that you can make, and oxygen makes the least amount of product. It makes 45.05 grams, which is smaller than 133.8 grams. So oxygen would be the limiting reagent or the limiting reactant. Because now that we know that oxygen is the limiting reactant, we need to find out how many grams of the excess reactant is left over. We know the limiting reactant has 0 grams left over, so there is no oxygen left over. So now we need to find out how much hydrogen is left over. So what we're going to do is we're going to start out with 40 grams of oxygen. And from that, we need to find out how much hydrogen is left over because it is our limiting reactant. So we're going to draw our little mole map here. We always go to moles first. We go from grams of oxygen to moles of oxygen, and then from moles of oxygen to moles of hydrogen, and then from moles of hydrogen to grams of hydrogen. So we have 40 grams of O2, and it says here that we need to go to moles of oxygen first. So I'm going to put moles of O2 on the top. Whatever units I have on the upper left always go on the lower right, so grams of O2. I am going to look at my units here to help me to determine what numbers I put here. If it is not a mole, and it isn't, it's a gram mole, we always put 1 next to the mole. Grams per mole of oxygen, that's molar mass. So I'm going to look at the periodic table and find out what the molar mass of oxygen is, or the atomic mass of oxygen element, times 2, because there are 2 of them, and that happens to be 2 times 16, which is 32 grams. I don't want to stop at moles, so I am going to draw another grid here. And it says we're going to go to moles of hydrogen. So I'm going to write moles of H2. Whatever units I have on the upper left, I always put on the lower right. So I'm going to do moles of O2. This is a mole-mole ratio right here, mole-mole, so we can't just assume that it's 1. And we always look at the balanced chemical equation for mole ratios. Moles of hydrogen is 2. So I'm going to write a 2 there. Moles of oxygen, right here is moles of oxygen, it is 1, so I'm going to write a 1 right there. We are at moles of hydrogen. Moles of hydrogen, we now need to go to grams of hydrogen, so I'm going to write grams of hydrogen right here. And whatever units I have on the upper left, I always put on the lower right, so moles of H2. I look at my units here to help me determine what numbers I put in front. I have a gram mole. If it's not a mole, I always put a 1 next to the mole. Grams per mole of H2, that's molar mass. So I look on the periodic table to find the atomic mass of hydrogen. Then I multiply it by 2 because there are 2 H's in this compound. And 2 times 1.01 is 2.02 grams. 40 divided by 32 times 2 times 2.02 is 5.05 grams of hydrogen. So what that means is when we react 40 grams of oxygen with hydrogen, we're only going to use 5 grams of hydrogen until all the oxygen is used up. Since oxygen is our limiting reactant, we started out with 15 grams of hydrogen. So to find out how much excess reactant, which hydrogen is our excess reactant, we take our starting amount, which is 15 grams, and we subtract our used amount, which is 5.05 grams, and that equals 9.95 grams of hydrogen is left over. That is the amount of excess reactant that we have left over. Thanks for watching.